This video is going to have a look at how the IC maths resources can be used to help children to understand the concepts and answer some of the questions from the 2025 Maths SATS questions. For question 1, I thought this was an interesting one. Circle the angle that is closest in size to a right angle. Now, would children be able to answer that without measuring and calculating for all those angles? There's some example questions that I've written from IC Reasoning Year 5 that I hope help children to be able to do that. Order the angles from smallest to largest without using a protractor. And can children order them without looking at the size of the angle section or the lengths of the lines, but looking at the amount of turn? I often find that trying to make those angles with a pair of scissors can help to do that. And this one is slightly more challenging, but it's a very similar idea. Is each angle acute, a right angle, or obtuse? And how can we know? Essentially by counting the squares, but not having to use a protractor. And then, of course, their children reasoning as to how they would know. Question 9 on paper 2, we had this example, and I've practically outworked this so many times with matchsticks. So Ali has 35 red counters. He divides them into groups of 3. What's the greatest number of groups of 3 he can make? And the example question below. And actually, this one really comes from some of the examples in IC Reasoning Year 3, where I've given children a certain number of matchsticks. So, for example, giving children 20 matchsticks, and then figuring out how many 3s can you make with 20 matchsticks, or how many triangles, how many 4s can you make, or how many squares, and so on. And then, say, explain the mistake examples. With 13 matchsticks, 3 triangles can be made and 4 are left over, and realizing I could make another triangle with 3 of those 4 leftover matchsticks. This one really made me laugh. Now, for the first 3 of the tick boxes, children can answer them by performing calculations, but the last one, it said the tallest animal is also the heaviest. And the reason I found this quite funny is I've actually explored this very concept in IC Reasoning Key Stage 1. And here, the children having to be able to recognize that the giraffe is taller and lighter than an elephant, and an elephant is heavier and shorter than a giraffe. Then we get to probably some of the slightly more challenging content, where the children have to work out where the circle needs to go to be able to complete the net. A precursor to that can be children being able to take different visual perspectives. So being able to describe what the dog can see, what the cat can see. So that would come before answering questions like this one from IC Reasoning Year 5, where the children have to be able to visualize where that 6th square needs to be drawn to complete the nets. Which ones are correct and which ones are incorrect. So developing that ability to be able to visualize those folds. This question is very similar to the SATS question. It's from IC problem solving for upper key stage 2. And children have to work out where do they need to draw the triangle so it's on the opposite face, and where do they need to draw the circle so that it's on the opposite face. Now, of course, some children will need support with that. And so the support prompt provides that. 2 tips to help children to reason and to be able to visualize where those shapes need to be drawn. And then a really challenging example from IC Reasoning Year 6, a similar thing where children have to be able to visualize nets being completed into cubes, and here drawing on 2 extra triangles onto each shape to complete them correctly. For this question, question 20, children need to be able to calculate the amount of the shape that's shaded by being able to visualize the relationship and understand the relationship between the part and the whole. Lots of example questions from IC Reasoning Year 6 that help children to do that. I like using estimation for this. So for children being able to look at the part and just being able to estimate, well, how many of the part do they think could fit in the whole? And then another example question on the bottom right helps children to reason around that. So which fractions do children see? They might just immediately know that the green section is a half, and then they might have to start reasoning as to the other sections. But again, visualizing the part to the whole and maybe putting some annotations on. And then moving on to this example, what fraction of the square is blue? And then again, children needing to put different annotations on and breaking that section up. And then eventually they can calculate that it's 3/16. This one's a classic one when it comes to pie charts and reasoning around pie charts. Now, of course, the big idea is that we know that a half is more than a third, but this is such a common thing to try and get the children to unpick. The key idea, of course, here is that a third of 36 is more than half of 20. Now, this big idea is explored in deconstructing worded questions for year 6. So in short, we've got 2 pie charts, and it would seem evident that we won more matches this season than last season. Now, we won a higher proportion of matches this season than last season, but of course, it's the same big idea. We played so many more matches last season that we ended up having more wins in total. To see the big vision for how we can build children as problem solvers, go to icmaths.com, the vision building problem solvers. Here, I've mapped out the key things that we need to do to build children as problem solvers, from building the reasoning routines, some videos there, deconstructing worded questions and the pedagogies that help children with that, to how we help to create sequences of challenges in problem solving. Have a look at those videos too.